Good afternoon to everyone. Myself MV Kiran Kumar. I am the assistant professor in mechanical department. I am teaching today's topic is Simplex Method. Simplex Method is in operation research. The Simplex Method is useful for dealing the variables of LPP formation. In the LPP formation, if we are having only two variables, that is x1, x2. If only two variables are there, then we have to go for solving graphical method. If more than two variables, that means x1, x2, x3, x1, x2, x3, x4 and so on, number of variables are there, then we have to go for simplex method. The simplex method is suitable for more than two variables. Having more than two variables, it is suitable. So coming to the simplex method basic condition is the objective function is maximization. So objective function is maximization. If the problem is given in the minimization condition, we have to convert it into standard form. The standard form is maximization. If the problem is minimization, so minimization objective function into -1. Minimization objective function into -1, then it convert into maximization. So the minimization problem is converted into maximization by multiplying the objective function with -1. So the minimization problem can be converted. So this is the first condition. Second condition is constraints. So the constraints in the simplex method is completely greater than type of constraints. So if the less than type of constraints, if the constraints are in greater than type of constraints, we can convert into less than. Second condition is constraints. So here the constraints are compulsory in less than type of constraints. If in the problem the constraints are greater than type of constraints, so we can convert it into less than type of constraints. Here also the condition is multiply with -1. So if we multiply the constraint with -1, then it will be converted into less than type of constraints. So the main thing is objective function is maximization and constraints are less than type of constraint. Then we can go for simplex method. So here one more condition is adding slack variables. So if the constraint is less than type of constraint, so we add slack variables. So slack variables means only plus terms, plus S1, plus S2, plus S3. Like these terms are we can add. So if the constraint is greater than type of constraint, so we can add surplus variables. So the surplus variables are indicated with -S1, -S2, -S3. Like that we can indicate negative terms of S values. So if the surplus variables are coming in the constraints, immediately we can add artificial variables. So artificial variables are indicated with A1, A2, A3, like that we can indicate. So and if the constraints is equal to type of constraints, only we can add artificial variables. Here also the artificial variables are A1, A2, A3 and so on we can add. So these are the main basic terminology that we have to solve the simplex method problems. So main thing is objective function maximization, constraints. Second thing, constraints, less than type of constraint, and the third one is after taking the constraints and objective function in the standard form, we can add slack variables only. In the simplex method we can add only slack variables. In the further conditions like big M method, two-phase method or dual simplex method, we add surplus variables and artificial variables. But in the simplex method only we are adding slack variables. In the today's session we are dealing with only simplex method problem. Okay, the problem is maximize z is equal to 2x1 plus 2x2 minus 10x3 is subjected to 2x1 plus 20x2 plus 4x3 less than or equal to 15, 6x1 plus 20x2 plus 4x3 less than or equal to 20, and x1 x2 are greater than or equal to 0. Here the objective function is maximize. So the given problem is in the standard form, maximization form, and constraints is subjected to, the constraints are two constraints they are given. The two constraints are in the form of less than type of constraints. So here the condition is less than, so both the constraints are in less than form. So no need to convert into any other form. So directly we can solve. So what I said in the previous is, here the problem is in the standard form. So we can add slack variables. So for constraints, I am adding slack variable 2x1 plus 20x2 plus 4x3 plus slack variable is adding plus s terms. So plus s1 is equal to 15. Why we are adding slack variable means we are converting the inequality type. So less than type of constraint converted into equality. So we add one more term s1. This means slack variable added for only converting the inequality to equality type of constraints. And the second constraint is 6x1 plus 20x2 plus 4x3 plus 1s2. So here 1s1 and here 1s2 is equal to 20. So the complete problem constraints equations are converted into equality form. Now we can write the new objective function z new. Z new is the new objective function. So original objective function is same, no need to change. So 2x1 plus 2x2 minus 10x3. These terms are no need to change. So here we are introducing the slack variables s1, s2. So right up in the here also. So s1 plus s2. So here after adding the slack variables in the new objective function, the original objective function may not be changed. So for that we are adding here the coefficient value as 0. So 0 s1, 0 s2. So this is the new objective function. So after writing up the new objective function, we can find IBFS values. IBFS, initial basic feasible solutions. So initial basic feasible solution means the two constraint equations, what are the common terms are there that can be placed as 0. That means we can assume x1 comma x2 comma x3 is equal to 0. Only assumption. For finding the remaining solution values, s1, s2 are the solution values. So for finding the s1, s2 values, we assume x1, x2, x3 is equal to 0. So that means first constraint equation s1 is equal to 15, s2 is equal to 20. These are the solution values. These s1, s2 terms are indicated as solution values. Now we have to write the initial basic simplex tabular column. So it can be written as CB, coefficient of the basic variable. Next, basic variable solution values. Next, basic objective function variables. So the basic objective function variables are x1, x2, x3. Next, solution new objective function, we are adding two more terms, s1 and s2. So after that, minimum ratio. So this is the tabular column. So here basic variables means after introducing the after finding the IBFS values, we are having s1, s2 terms are the basic variables. Only two variables are there. So s1, s2 and solution values. Here we are getting solution values, s1 is equal to 15, s2 is equal to 20. So 15, 20 and new objective function s1 coefficient value is 0 and s2 coefficient value is 0. So coefficient in the basic function. So here 0, 0. And next x1, x2, x3, s1 values are from constraint equation. So x1 coefficient value 2, x2 coefficient value 20 and x3 coefficient value 4, s1 coefficient value 1. So for the first constraint, the coefficient values are 2, 20, 4, s1. There is no s2 term. So we are writing here as 0. For the second constraint, x1 6, x2 20, x3 4 and s1 term 0, s2 1. So after writing this, I am finding the zj values. Zj. So for finding the zj values, zj is equal to formula cb into xi. For finding the Zj values, Zj is equal to Cb into Xi. Cb means coefficient of the basic variable value into Xi means corresponding X1. Which column we are finding, that column we can consider. So the first thing is here the first up to solution values we don't have to find the value. We don't need to find that particular value. Next X1. Here Xi means X1. X1 means 0 into 2. So 0 into 2 plus 0 into 6. So 0 into 2 plus 0 into 6. So here 0 into anything. So every value is 0. So here two values are 0. So multiply with any value. Every value is 0. So 0, 0, 0, 0 and 0. Next Cj minus Zj. Cj minus Zj, or we can taken like that Zj minus Cj or Cj minus Zj. So if we are taking Cj minus Zj, here positive values coming. Here positive values coming. If any negative values are all Cj minus Zj values are negative. All Cj minus Zj values are negative and Cj minus Zj values are 0. Then the problem will be completed. If any positive value is of Cj minus Zj, then we can go for next iteration. So here we can check the values. So x1 coefficient value in the new object original objective function, x1 coefficient value is 2 and x2 coefficient value 2, x3 minus 10, s1 0, s2 0. So this one is 0. So that means Cj minus Zj values. Here Cj minus Zj values means Cj means the top coefficient. X1 variable top value is the coefficient value. So 2 minus 0, 2. Next 2 minus 0, 2 minus 10 minus 0, minus 10, 0, 0. So here Cj minus Zj values, if any positive values means go for next iteration. If in all values of Cj minus Zj are negative or 0, then go close the iterations. So here we are getting two positive values. Choose any one. If the value is same, then choose any one. If the values are different, like if the first value is 5, second value is 4, then choose the highest value, highest positive value, which whatever we come. Here the value we can choose. That means 5 we can choose. But here in this problem, we are having 2 is the common value. So there is the common value means choose any one value. So I am choosing the first one. So this term is considered as key column. This term is written as key column. 2 is the key column. So the key column values we can note it as a box. So key column identified. Next key row, we have to find key row. Why we are finding key column and key row? So what is the next iteration? So for the coming next iteration, we have to eliminate the row value, the particular key element value. For finding the key element value, we have to find key column and key row values. So key row value will be coming by finding the minimum ratio values. Next, minimum ratio we have to find. So for finding the minimum ratio, the last column for finding the minimum ratio, the formula is solution value by key column value. SV, solution value by key column value. Solution value by key column value. So for finding the minimum value, minimum ratio, the formula is solution value by key column value. So for the first one, 15 divided by 2. 15 divided by 2, that means 7.5. And next one is 20 divided by 6. 20 divided by 6 means 3.2. So 3.2 or 3.4 something. So here we are writing the values, so minimum ratio values. For finding the minimum ratio, 15 divided by 2, first one is 7.5 and the second one is 20 divided by 6, 3.4 something. So here the minimum, here we are mentioning minimum ratio. That means minimum value is the key row value. Minimum value whatever we get, that will be considered as key row value. So here also write a box. The common element, key column and key row values, common element, whatever we get, that element is considered as a key element. So here the 6th term, 6 is the key element. The term 6 is considered as a key element. Next. So next iteration, for the next iteration, the Tableau column will be changes. So for that we have to write the value next iteration Tableau column. That means row. first row, here we get the 6 value as in the second row. So row 2 new is equal to row 2 old divided by whatever the value we are having here, 6. So by dividing the value with same value, we can get 1, the term 1. So here we are writing R2 new is equal to R2 old divided by 6, and the next value R1 new is written as R1 old minus R1 old minus. So here the basic terminology is whatever we get the key element, that element is make it as 1. So for that we are writing first we are writing the second element or second row operation, row 2 new is equal to row 2 old divided by 6. So that means here we can get the value as 1, and make it by using these row values, second row values, we can convert the remaining rows and the corresponding key column element, make it as 0. So here in the place of 2 we can make it as 0. So for that we are writing row 1 new is equal to row 1 old minus multiplication factor 2 into, in the new row second row we are getting 1, so multiply with row 2 new. So these two are the row operations for the next iteration. So row 2 new is equal to row 2 old divided by 6, and row 1 new is equal to row 1 old minus multiplication factor into row 2 new, newly formed second row. So this is the initial simplex tabular column. For finding the next iteration tabular column, we have to write next tabular column CB, BV, CJ by solution values x1, x2, x3, s1, s2, minimum ratio. So basic variables are, what are the basic variables in the previous iteration table? In the previous tabular column, s2 is the main key row and key column main element. So we have to replace this s2 variable with x1. So here s2 is s2 is called as outgoing variable, outgoing or exit variable. Outgoing s2 term is considered as outgoing or exit variable. So here in place of s2 we can write it x1. So x1 is written taken as incoming or entering variable. So in the next iteration table we have to write in place of s2 x1, and the coefficient of the basic variable here x1 coefficient value 2. So in place of 0 we can write 2, and entire equation divided with 6. So s1 no change, in place of s2 x1 coefficient value here minus 10 0 0. So these are the main coefficient values, and new value basic variable is x1. In terms of s2 we can write x1, and the coefficient of x1 is 2, s1 no changes 0, and solution values. For the solution values, go for the previous table column. Here the solution values, first we are calculating the second row. Whatever the row we are directly first written row operations, row 2 new is equal to row 2 old divided by 6. So 20 divided by 6, 6 divided by 6, next 20 divided by 6, 4 divided by 6, like that we have to write. So first thing is 20 divided by 6, that means 3.4. Next 6 x1, here we get 6 by 6, so 1. Next in place of x2 20 means 20 by 6, 3.4, and x3 coefficient value. What is the x3 coefficient value? Here x3 coefficient value is 4 and remaining 0 1, so 4 by 6, that means 0.75. Next s1 0 divided by 6, 0, 1 divided by 6, that means 1 by 6 I am writing here. This is the new row we are forming. So by using this row we can solve the remaining first row values. So in the first row the values are, here the first row solution value is 15, next 2 20. So first value is 15. So here the new solution value is 15 minus whatever the multiplication factor we are saying 2 into 3.4. 15 minus 2 into 3.4. So 2 into 3.4 means here 6.8. So 15 minus 6.8, That means whatever the remaining value we are getting here, the value we are writing. So 5 plus 3, 8. So 8.2. Next, in place of x1, what is the value? In place of x1, 2. In place of x1, here the value is 2. 2 minus 2 into here new value is 1. So 2 minus 2, 0. Next, 20. x2, 20. 20 minus 2 into 3.4. So 20 minus 2 into 3.4 means 2 into 3.4, 7.8. Here 7.8. 20 minus 6.8. 20 minus 6.8. That means 13.2. So here new value is 13.2. Next, in place of x3. So in place of x3, previous value is 4. So 4 minus 2 into 0.75. So 2 into 0.75 means 1.5. 4 minus 1.5, that means 2.5. And the next value S1 is 1. So 1 minus 2 into here old value is 0. So 1 minus 2 into 0. So that means 1. In place of S2, 0 minus 2 into 1 by 6. That means 1 by 3. So these are the new values. This is the new simplex tabular column after the new operations, row operations completely done. So here we have to find the ZJ values and CJ minus ZJ values. So for this ZJ values we have to find ZJ. So ZJ formula is CB into XI. CB means here previously we are having both the values are 0. So directly we are taking as 0 into anything values, directly we are taking as zeros. But here we have value 2. So 0 into 0 plus 0 into 0 plus 2 into 1. That means here we are getting the value 2. Next, 0 into 13.2. So 0 into 13.2, 0 plus 2 into 3.4, 6.8. Next, 2 into 0.75, 1.5, 0. Next, 1 by 3. So these are the values we are getting, ZJ. Next, CJ minus ZJ. So CJ minus ZJ, here the values 2 minus CJ value is 2, 2 minus 2, 0. Next, 2 minus 6.8. 2 minus 6.8 means 4.8 minus 4.8 minus 10 minus 1.5 minus 10 minus 1.5 minus 11.5 and 0 minus 1 by 3. So as we discussed in the previously, all CJ minus ZJ values are either negative or 0. So we can stop the problem. Here CJ minus ZJ values are zeros and remaining terms are negative. So the problem is stopped here. So all CJ minus ZJ values either negative, 0, the problem will be stopped here. So corresponding X values, here only X1 will be replaced. So X1 term is equal to 3.4. So X1 is equal to 3.4 and X2. So X2 is not replaced. So considered as 0 and S1. S1 value replaced. So 0 and S1 solution value 8.2. S1 here solution value is 8.2. So the new objective function Z new is equal to 2x1 plus 2x2 minus 10x3 plus 0s1 plus 0s2. So in this function, new objective function, we can substitute the values x1, x2, s1 and here s2 is equal to 0. It is replaced. So 2 into 3.4 plus 2 into x2 term 0, here minus 10 into x3. So there is no x3 term, x3 not replaced. So we can take it as 0 plus 0 into s1 term, s1 value 8.2. So 0 into 8.2 plus 0. So 2 into 3.4 means 6.8 plus 2 into 0, 0 minus 0 plus 0 plus 0. So finally Z value is 6.8. Z max So whatever we are getting, the value is Z max. Z max is equal to 6.8 is the final solution value. Z max is the final solution value. Whatever we get the value, that value is considered as a maximization value. If the problem is in the minimization condition, as we are discussed in the starting position, so if the problem is Z minimum, we can convert the problem with multiplication with -1. So we can convert into maximization. So here also, after getting the maximization problem, if the problem is in the minimization condition, if we we can convert into maximization, and finally we can change the answer into minimization by getting the value into 6.8. Whatever get the value 6.8 into -1. So it will be converted into minimization condition. If the problem is given in the minimization condition, after getting the maximization value will be multiplied with -1, then the answer will be converted into minimization. So this is the basic simplex method procedure. Thank you all.